Welcome back, everyone. We are on lesson 4 of our Unit 5 Linear Relations Part 2, and this is the lesson on application. So I'm going to go through one word problem, and there are 7 different parts that relate to that one word problem. All right, here we go. So we've got Cindy, who is given $84 to spend on hamburgers and drinks for her friends at a baseball game. Hamburgers are going to cost $3.50 each, and drinks are going to cost $1.50 each. She's going to spend the entire $84. All right, so we need to write an expression to represent this information, but before we do that, we need to state what our letters in the expression are going to represent. So I'm going to pick H for the number of hamburgers, and I'm going to pick D for the number of drinks. Which variable is independent? So which of these depends on the other? Does the number of hamburgers depend on the number of drinks, or does the number of drinks depend on the number of hamburgers? Well, both answers are correct, right? In this case, it doesn't matter which is the independent and which is the dependent variable. Write an algebraic equation to represent the situation. So now we can write our expression. So I'm going to say cost is equal to 3.5h plus 1.5d, and then just represent my, or replace my cost with $84, because that's how much money she has to spend on the hamburgers and drinks. Can you determine if the relationship is linear or not based on the equation? Yes, you can, because none of the variables have an exponent that's bigger than 1. Right? If we had a 2, for example, on the h, then it would be a quadratic. But this is definitely going to be linear. All right, question 4. Determine each of the following. Part A, Cindy buys 12 hamburgers. How many drinks can she purchase? So if she spends, $3.50 times 12 on all the hamburgers, how much money is she going to have left over? And then that will have to get divided equally to the number of drinks that she can purchase. All right, so you can replace your hamburgers, your H, with 12. Right, and go from there. So $3.50 times 12 would be $42, which gets subtracted from the 84, and then divide both sides by $1.50 to figure out how many drinks. So it looks like she can buy 28 drinks if she purchases 12 hamburgers. Part C, can D be determined if you know H? Yes, it can. You have 2 variables in here. If we know the number of drinks, the amount of drinks, if we know D, then we can definitely figure out what H is. Okay, and same in the other way. If you're given the number of H, how many hamburgers you can buy, you can definitely figure out what drinks is going to be. Question 5, complete the following table of values and then answer the question. So I'm going to do the table of values first. So the way I did this is number of hamburgers is 0. So if she doesn't buy any hamburgers, how many drinks can she purchase? So just using our equation. There we go. Replace your H with 0 and then solve for D. So it looks like she can purchase 56 drinks. And then I did the same thing at the bottom here. If she purchases 0 drinks, right, how many hamburgers can she purchase? So replace D with 0, and it looks like it will be 24 hamburgers. And since this is linear, these values are going to be increasing by the same amount, all right? So the number between 0 and 24 would be 12, so we know this value would be 12. And what number is between 0 and 12? It would be 6. And the number between 12 and 24 would be 18, right? So these are increasing by 6. And the same thing will happen here, right? These are going to be decreasing by the same amount. So I start off by finding the number between 0 and 56, which is 28. And then the number between 0 and 28 is 14. And between 56 and 28 would be 42. The other thing you could do is, once you get these values here, you can plug them into the original equation to find the missing values for D. What type of correlation exists between the 2 variables? Well, notice how as the number of hamburgers increases, what is happening to the number of drinks, right? Those values are decreasing. The more hamburgers you buy, the less drinks you can buy. So that means it's a negative correlation. right? As one thing is increasing, the other one is decreasing would be negative. Is the relationship linear or not based on the table of values? So looking at the table of values, what you want to check for are first differences. So maybe, I'm not sure if you remember, but we did this before we went on March break, right? The way you find first differences is you subtract the bottom number from the top number. So 42 minus 56, right, is going to give you negative 14. These are decreasing, right? What are these going down by? They're going down by 14. So since they're decreasing, it has to be negative. And because these are all equal to each other, for sure this is linear. So that's how you tell by looking at the values in a chart. Okay, question 6, graph the relationship. So I did that already here. So using the table of values on the previous page, I plotted my points. Should the points be joined? So is it okay for us to draw a straight line through these? Okay, I'm going to say no, because if you do that, you are saying that all the values between 0 and 6 are included. All right, so is it, I mean, whole numbers would be, right? You can buy 1 hamburger, 2 hamburgers, 3 hamburgers, and so on, but can you buy 1.1 hamburgers? Right? If you include a straight line, you're including all the decimal values in between as well. And it doesn't make sense to have, 1.5 hamburgers. So no, it's not okay to join those points, right? That data is not continuous. That data would be discrete because you can only include whole numbers. What is the slope of the line? So to figure out the slope of the line, you're just looking at what is the rise over run, right? So how do you get from, this point to that point here, right? What are you going down by and what are you going across by, right? You're going to go down by 14 and you're going to go across by 6. All right, so our slope is negative 14 over 6. And you can write that in lowest terms as negative 7 over 3. The other thing you might notice, if we go back up and look at our chart, right, negative 14 over 6 was our slope. Look at that. We've got negative 14 over here as our first differences, and the 6 would come from these differences here, right? These are increasing by 6. So you can actually get the slope from looking at the values in the chart and doing the first differences on both sides. They need to correspond. Explain the significance of the slope. So for this example here, if you buy 7 less drinks, you can buy 7 more hamburgers. A couple notes. In this graph, H was the independent variable to agree with the table of values, but it didn't really have to be independent, right? We could have had drinks on the independent in the independent column. I just chose hamburgers randomly. A complete graph shows all possible solutions to the equation. So we only have a bunch of points that we included, but there are other possibilities, right? For like we only had values for 6 hamburgers, 12, 18, 24, and 0. But there are other values in between there. I didn't plot all of them. And then some solutions may not be acceptable due to restrictions in the problem. So for example, the number of hamburgers, number of drinks should be whole numbers. That's what I talked about a couple minutes ago. Right? You only need to have whole numbers. And the last question, determine each of the following. What is the intercept for the horizontal axis? So this is our horizontal axis down here, and it's asking for the intercept. So where do we cross the x-axis or the h-axis in this case? We cross that number 24. So the h-intercept would be 24. And what is that as an actual ordered pair? So like the actual point, it would be 24, 0. And what does that mean? What does this 24 mean in relationship to the problem? Well, it means that if you buy 24 hamburgers, you can't buy any drinks. All of your money is spent on hamburgers. What is the intercept for the vertical axis? So the vertical axis, which is D, right, it would be 56. And that ordered pair would be 0, 56. And what does that mean? It means that if you buy 56 drinks, you cannot buy any hamburgers because you're not going to have any money left. And the last slide. So question 7G, can there be a negative value for H? Can you have negative hamburgers? No, you can't have negative hamburgers and you can't have negative drinks. So they have to be positive values. And what are the restrictions for H? So looking at H, all the values that we have, you can see that the most number of hamburgers you can buy is 24 and the least number is 0. So we have, the restrictions are that H has to be between 0 and 24. And the proper way to write this would be H is less than or equal to 24. H is bigger than or equal to 0. And same for D. You can only buy between 0 and 56 drinks. So your value D has to be less than or equal to 56. D has to be bigger than or equal to 0. So those are the restrictions. That's the end of the lesson. For homework, you are working on the lesson 4 homework in this unit, and it's on page 6 of the homework booklet that you have, and then the solutions are on page 7. Make sure that you are showing your work as much as possible. All right, good luck with your homework.